Evidence 1 Matter and Energy. The name of this topic is History of Physics. We will see 6 of the most important physics who contribute and create a great impact on the world. I will also explain what is physics and how many parts it is divided into. Physics is one of the oldest sciences. Astronomy is one of its areas studied since ancient times. It was led to great discoveries prior to Middle Ages. Astronomy was considered as a part of philosophy, becoming a modern science during the scientific revolution in the 17th century. Nowadays, one of the interests of physics is to provide knowledge, from the basic to the complex, such as evolutionary and discerning between order of magnitude, as well as developing a clear perception of situations that, being physically different, display certain analogies that allow applying previously known situations to new problems. Here in this photo, we can see Aristotle, Archimedes, Galileo Galilei, Isaac Newton, James Clerk, and Albert Einstein. All these men had the necessity to understand and explain all the natural phenomena that surrounds him. I put here some of the things that they discovered and who were they. I think that the 6 are very important because thanks to them we see things as we have them today, and they made the world a better place with their knowledge and discoveries. But I think one of the most important that has the greatest impact is Albert Einstein, because he developed the theory of relativity, discovered the photoelectric effect, and did the contribution of the quantum bomb theory. Physics is one of the oldest sciences. Astronomy is one of its areas, studied since ancient times. It has led to the great discoveries. Prior to the Middle Ages, astronomy was considered as a part of philosophy, becoming a modern science during the scientific revolution in the 17th century. Nowadays, physics is divided in two big branches. First one, the classic physics, deals with a small velocity when compared with light speed. And the second one is the modern physics. It's considered one of the quantum and relativity theories, and it deals with velocities near to light speed. The second topic is measurements and unit. Here in this topic we will see the type of errors in a direct measurement, the international system of units, the delivered units, the scientific notation, and the conversion of units and the use of scientific calculator. Measurements and units. A physical quantity is a quantifiable or assignable property that is linked to a phenomenon, body, or substance. A physical quantity is measured when comparing it with a previous known standard. Examples of a physical quantities are mass, weight, length, time, etc. Standard, magnitude, and unit are some examples of physical quantity. Measuring is a process that consists in comparing an unknown magnitude and another already known in the same unit of measure. Here we can see two types of measurements. Direct measuring, that means that the unknown magnitude is measured with an instrument of the same magnitude, and indirect measurements, that means that the unknown magnitude is measured throughout the mathematician calculations. Types of error in a direct measurement. First one, the systematic error, is caused due to an imperfect calibration of the measurement instrument, and it is very frequent. The second one is the random error. It occurs when the magnitude varies randomly and it is difficult to anticipate and not very common. The third one is the absolute error. It is the difference between the real value of a magnitude and the measured value. And the last one is relative error. It is the fraction resulting from the ratio of the absolute error and the measured magnitude. It is usually expressed as a percentage. International System of Units is commonly known as SI. Is the most used unit system around the world. It is regulated by several bodies located in Paris and France. The SI defines several fundamental quantities which have assigned several basic units and their symbols. The most common symbols are meter, kilogram, and second. And here we can see a table where they put some of the magnitude units and symbol. Delivery units. It is possible to measure many more units like volume, pressure, speed, and force. All these are combinations of fundamental units, and these combinations are known as delivered units. Here in the next chart, you can see several units of the United States customarily unit system known as USCU. Scientific notation. The scientific notation provides a short method to show really big or really small numbers. In the first example, you can notice there is no prefix for the fourth power, so that is why you can use the closest one. In the second example, the same happens when working with the negative powers. For example, in the last example, it will be better to use the example that is over there, and it is also valid to add a zero to the right too. Conversion of units and the use of scientific calculator. In order to convert units from the same system to another one or keep the inside the same, we need to know a conversion factor. A conversion factor is equivalence between units, and it is almost sure that you know the several factors, like the ones you can see over there. However, some factors are provided to you in order to perform conversions from the SI to the USCU or other units that you don't use quite often. Over there, in the last example, we can see all the examples of 1FT, 1NI, 1MI, or 1JD. Dimensional analysis of quantities. The dimensional analysis of quantities is very important in physics. The advantages are the following. Number 1. Simplifies producers and involves different physical magnitudes. Number 2. It can scale to analyze simpler units. Number 3. Implies experimental process. Number 4. It is useful in scale experiments which are fundamental in fields of aeronautics, automobile designs and construction, etc. Number 5. Helps detect error. And number 6. Confirms the validity in the experiments. Topic 3. Scalar and vector quantities. In this topic, we will see the definition of a vector and scalar quantities. We will see the graphic representation of a vector in 1 or 2 dimensions, and we will see the analytical representation of a vector, regular, and polar coordinate system. Definition of a vector and scalar quantities. Some quantities can be described only by its number and a unit. These kind of quantities are called scalar. A scalar quantity is specified completely by a magnitude that is a number and a unit. Here we can see some examples. Some physical quantities such as force and velocity have direction and also magnitude. That's why they are known as vector quantities. The direction should be considered in any calculator that has these quantities. A vector quantity is completely specified by magnitude and direction. It consists in a number, a unit, and a direction. Here we can see an example. As you notice, the direction of a vector quantities could be provided by a coordinate points, angles, or a mix of both of them. In order to represent a variable that is a vector quantities, we can use both front of a little arrow, both the variable. Example, the one that you can see over there. Graphic representation of a vector in 1 and 2 dimensions. A vector is a graphical representation of a vector quantity. It is represented by an arrow where its leg points out of magnitudes, and the tip shows the direction. To draw a vector, we should pick a scale that helps us to represent better its magnitude in our notebooks or in the board of your teacher. Most of the times the scale can be 1:1, like the example that is over there. Maybe to some of us it is easier to obtain the length of the vector. It is important that you learn how to show scales mathematically in order to be sure of your results. To show the direction of the vector graphically, as we saw before, we can use cardinal points like north up, south down, east right, and west left. Another common way to show direction it is using degrees, outer clockwise and starting from the right side, since the positive is x and you can see in the figure below. Analytical representation of a vector, regular and polar coordinate system. For any vector with magnitude r and direction 0, we can obtain its components along that x and y axis using the following formulas. That is the example that is below. For example, if we have a vector f 216 grades, we can obtain its components for each axis, like the example below. Operation with vectors. In this topic, we will see the graphical and analytical methods for a vector and the addition, the disadvantages, and the multiplying of a vector by a scalar product and cross product. Graphical and analytical methods for vector addition. The result of a vector sum is known as resultant vector. R equals A plus B plus C. This sum cannot be solved in a traditional way. That is the reason we need new methods to do it. There are two methods to sum vector grammatically. First one, parallelogram method, and second one, the tail-to-tip method. The parallelogram method only works for the two vectors. First, you need to draw with a proper scale both vectors coming from the same origin point. Then, with the use of triangles, draw parallel auxiliary lines that are going to touch the tip of each vector. Doing this, an intersection of the auxiliary lines is formed. The result of the vector sum is the resultant vector that is formed when the origin point and the intersection are joined together. The tip of the resultant vector is at the intersection, and the direction is measurement from the origin point. Disadvantages. The main disadvantage of this method is that they are inaccurate and they rely on our measurement skills, so that's why we need to learn a method we can trust on. Another disadvantage is that the component method is the most used of adding vectors in physics and is mandatory that you understand it. Another disadvantage is to add two or more vectors using the component method we have to. Another disadvantage is this composite vector that we can want to add into its component. Multiplying a vector by scalar, don't use product and cross products. Just like scalar quantities can be multiplied with other quantities, vectors too. However, there are three types of product that we involve vectors, and it is important that you know them. So in the future physics course, you are going to learn to do and apply. Here we can see a table with vector scalar product. The product of a scalar with a vector only changes the magnitude of a vector, but does not mess direction. And here we can see an example. Then dot product. This kind of product between two vectors is also called scalar because the product result is a number that means a scalar quantity. And here we can see an example. Cross product. This kind of product between two vectors is also called scalar product because it results a vector quantity, and here we can see an example. Topic 5 and the last one. Description of movements in one dimension. In this topic, we will see analytical description of movements from position function. We will see movements description from position and velocity graphs. We will see analytical description of movements from a position function. And last one, we will see rate of change, velocity, and acceleration. Analytical description of movements from a position function. Every day we use without distinction the word distance and displacement. However, in physics their definitions are quite different. Distance is the length of the real path followed by an object. It only has magnitude, so it's a scalar quantity. We normally use d or s, commonly for curved trajectory. so represent it on formulas. Also, we can use the variable x if we talk about an horizontal trajectory. Displacement is the separation in a straight line between 2 points, the final and initial positions, and it goes into precise direction. It is a vector quantity, so it has magnitude and direction. They represent in formulas we use the t, and remember that is both because it's a vector. Sometimes it's also called change of position. Instantaneous speed is a scalar quantity that represents the speed in that extent in which the object is a given point c. Instantaneous velocity is a vector quantity that represents the vi velocity at any point c. Acceleration is the rate of change of velocity per unit or time. A positive velocity means that an object is moving to the right. A negative velocity means that the object is moving to the left. A positive acceleration means an object is moving to the right. A negative acceleration is when an object is moving to the right and means that the velocity will decrease to the right too. A positive acceleration is when an object is moving to the left and means that its velocity will increase to the left too. A negative acceleration is when an object is moving to the left and means that its velocity will decrease to the left too. Movement description for position and velocity graphs. We can have three kinds of graphs to analyze the motion and object. First one position, second one velocity, and third one acceleration. First, if the velocity is constant, it means that acceleration is zero, so the velocity will not decrease or not increase. Here we can see some example in a graph. As we can see in the last graph, the acceleration green is always zero. Thus the velocity red does not increase or not decrease and remains constant. This causes that the position graph blue is aligned with a positive slope. Now we analyze the behavior of a negative constant velocity, and here we can see an example in the graph. Rate of change, velocity, and acceleration. The rate of change is velocity. It refers to how the displacement is changing regarding to time. For example, a constant speed of 8 ms indicates that the object moved 8 meters per second. Instantaneous velocity. It refers to how the displacement of the object changes. The acceleration as the rate of change. It refers to how the velocity is changing with respect to time. And instantaneous acceleration, it refers to how the velocity of object change.